you draw? How do you show certain things? For example, if I have a line and I draw the line, you need 2 points for the line, obviously. Line AB, I would say it's line AB. Or what's the other way? BA, right. Now, we can write lines going either direction. But when you label it, what do you have to have above the letters? What's that? Yeah, with the arrows. Yep. You gotta have the arrow stuff above it when you're talking about a line. You have to, okay? If you don't, it doesn't work. Then it just says it's a segment, okay? Now, the other part on here, there was another way to write a line. Do you remember the other way we wrote lines? What's the other way we wrote lines? Another way to label them. You don't see it very often, but you remember? How about lowercase cursive? Line L. It's another way of doing it, okay? We use cursive letters every once in a while in here. Lowercase cursive shows lines. What did the uppercase cursive letter show? Do you remember that?
Raise.
What's that?
Raise.
No. What's that? Nope. Cursive. Nope. Plane. How many points do you need to make a plane?
Isn't it 4?
3. Now, more specifically, what type of points? A plane is made up by 3. What kind of points? Should it be collinear or non-collinear? Non-collinear. They have to be 3 non-collinear points.
Not the same.
Correct. Because if they're wind up being collinear, it doesn't show that it's it would just show that it's a line. It doesn't show that it's an actual plane. So a plane is made up by 3 non-collinear points. Again, when they label it out, it usually just say plane ABC, or sometimes they'll use a capital cursive letter, R, something like that. Rays. What is, with every ray, what is always the first letter? See what you did there. Boo. What's that? No. What about when you label a ray? So if I have a ray X, Y. When I say if I have a ray X, Y, what's my endpoint here? Y. It's Y.
Because X.
Because the arrow's going this way. So your endpoint when you draw it would be the Y. I was saying it backwards to see if you would catch on that. Remember, when you have a ray, the spot that does not have the arrow is always the endpoint. Okay, it's always the endpoint. So this would be, oops, the X and the Y kind of look exactly the same. Okay. What do opposite rays create? Lines, good. Opposite rays create lines. Opposite rays create lines.
I hope so.
Oops. Remember we had that question on the quiz that was about opposite rays. Ray BA and ray BC are opposite rays. They create a line. Okay. That was one thing we talked about. Really, in the first section, most of the stuff was all about, labels and points and stuff like that. Wasn't a lot of craziness there. There wasn't even real math yet. It was just getting accustomed to the terminology and the definitions of things. But as you get further into it, we start talking about segments. Now, line segments then have definitive endpoints. Segment AB, it's a definitive measurement. Segments can be measured. They can be given value. there is no numerical value to a line. There is no numerical value to a ray. They have certain coordinates you can pull from, but you can't measure them because they're infinite. Okay? Excuse me. A segment, on the other hand, you can. You can say, oh, this is 12. Yay. All right, things like that, which allowed us then to get to segment addition. Segment addition basically told you the following. Two smaller segments add up to equal a larger. So if this is 8, this is 19. What's the missing part? Bless you. Yes, sir. What's YZ? 11. Exactly. Two smaller segments add up to equal the larger. That's what segment addition allows you to do. And remember, segment addition and angle addition are kind of the same thing. It allows you to do that. Which means you could then look at problems like this. I think this one said B is between A and C on AC. That was the instructions for something like this. Yes, sir.
Are you going to give us like what you back into?
So if it says something like this, where you have B is between A and C on segment AC, what should you do? Besides texting, put away your phone, please. Draw it, exactly. Draw it. Draw it. Always draw pictures, guys. And fill in the blanks. So you start writing them out. Okay.
Oh, I feel stupid.
What do you do? Yes, ma'am.
X plus 6, wait, that's 16.
Yeah.
Plus X plus 16.
That's all it is. Now you have your two smaller equal to large. So your x 16, x is 16. Oops, I'm swiping right. What's 16 and 16?
32.
32. So you have 2x and a 32 is 24. How do you move the 32? Subtract it. And then you divide it by 2. Now, is it okay that you have a negative value for x?
Yeah.
Yes. It's the segment isn't negative, just the value of x is. So if you substitute back in, what's negative 4 plus 16? 12. And this is 12. Isn't 12 plus 12 24?
Yeah.
That's how it works, guys. You can get negative values for segments. I'm not for segments. For x. Well, I didn't know there were going to be. But when you substitute in, you still have a positive value, okay? So it still works. That does not change. It never changed. We also had stuff. Let's see which one is this? Is one. This one. We also had the straight algebra problem. What's that? Yeah, the segment stuff, yes, part of the segment stuff. So if we start going into things like this then, if you have to start solving for x to be able to substitute something else in, you're still using the same exact steps. You're still doing all the same properties. In this case, though, it actually gave you a picture. So if you have this on a test, then you have a picture there, you fill in the blanks and you write it out. Now, two smaller segments add up to equal the whole. Write down the algebra. I know 14, 3x minus 4 is 4x plus 4. Because that's what it says. Okay.
We still need to say answer if we could do 3x minus 4 minus 14.
It's not minus 14, it's,
Plus 14.
yeah, because what's 2 plus 3?
5.
What's 3 plus 2?
And 5.
Good job.
Does the order matter? He's just like, oh man. Does the order matter when you add? It's the same thing. Oops. And as you see, this winds up being really fast. Subtract 4 from both sides, subtract 3x from both sides, and you get 6. Okay? But it asks you to solve for AC, which means you substitute back in. Now, if you substitute back in, what's 4 times 6? Add 4. 28. And does it take forever just to double check, make sure you didn't screw up here? Well, what's 12 minus 4? 8. And 8 and 14 is still, oops, excuse me. Oh, I wrote 4, that's why. How about if I use 6? That might be helpful. So 18 minus 4 is 14, so yeah, that might work it out. Sorry about that. But at least I knew I screwed up, so something was wrong, so I went back and double checked it. Now, in this case then, what is point B? Point B has no value, it's just, but what is point B in this example?
Midpoint.
It's a midpoint, good. Why is it a midpoint?
It's in the middle.
It's in the middle.
It's in the middle because these are both of both. They're both measured 14. They have equal measurements, so that means B is in the middle of AC, so it is a midpoint. Okay. It's a bisector. Remember, segment bisector can be a midpoint, a point that cuts something in half. Let's see, what was the other one that we had on that? After we did those, we started talking about these three things. We had distance, a midpoint, and a missing endpoint. And this is where a lot of you guys messed up some stuff on the quiz. You didn't read it carefully. It was a distance, all of a sudden you were finding midpoints. It was a midpoint, you were finding distance. So remember, there are three different things. It says distance. Well, remember, the distance formula is that long-winded square root problem. Change in x, and change in y, 180 squared. Or remember, we did it as a shortcut. We talked about it in terms of horizontal change, vertical change, and we used Pythagorean theorem. It works the same way. Okay? It works the exact same way. So what I want to do is use this set of ordered pairs here. Let's see, it's -4, 3. Excuse me. No, I'm trying to think of. 11. We'll do that. So I'm going to go two different ways of solving that out. One way, remember, is to use the distance formula, the actual long-winded setup for it. The other way was to just find the differences in the values and square them. It's the same thing for either way. If I use the logic way, I'm just going to ask myself, how far apart is -4 and -10? 6. So my first part would be 6, and then I square it. How far apart is 3 and 11? 8. So I would square it. So I'd figure out what those two are, squared, add them together, and then take the square root. So what's 6 squared? What's 8 squared? So I'm looking for the square root of 36 plus 64, otherwise known as the square root of 100, which is 10. Good. So that means the distance between those 2 points is 10 units, whatever it winds up being. Okay? That's how far apart they are. Now, what's different between that versus a midpoint is that the midpoint is looking for the halfway spot between the 2 points. So when you do that, you're adding the two x values together, cutting it in half. Adding two y values together and cutting it in half. So your midpoint, you add them, you're finding the average. So what's -4 plus -10? What's half of -14? -7. So this ordered pair has a midpoint then at -7, comma, what's 3 plus 11? What's half of 14? 7. So this has a midpoint then, a halfway spot at -7 and 7. Okay. And then the last part is if you did the missing endpoint. If you knew you had a midpoint and you had to find a missing endpoint, we'll reuse the same thing here. Let me move this up. So point A was -4 and 3. The midpoint was at, what did I say it was? -10 and 11. Where's point B for the missing endpoint? What did you do for this method?
You'd see like, how many, -14, 15.
You going up or down?
Yeah.
How much?
6.
What's 6 fewer than -10?
Oh,
I'm moving down 6, so I need to go down 6 more.
-16.
-16. Okay. Do the same thing. 3 to 11, up or down? How many? What's 8 more than 11? There's your missing endpoint. A lot of you guys mixed up all 3 of those methods. A lot of you guys mixed up all 3 of those. Please, 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 read carefully. If it says distance, find the distance. If it says find the midpoint, find the midpoint. If it says find the missing endpoint, given the endpoint and a midpoint, find the missing endpoint. Okay? You got to know the differences and how to set it up. And that's where you guys made mistakes. Okay? That was about everything we did in segments, wasn't it? Oh, what happens if you do have a segment bisector? What do you do to the segments? How do you solve it? M bisected it, didn't it? We know it's bisected because of what? Yeah, the tick marks, right? So what do you do algebraically then? Exactly. Whenever you have bisectors or a midpoint, whether it is a segment bisector or in a second we'll talk about an angle bisector, that means it's been cut into 2 equal parts. Algebraically, just set them equal to each other, and that's it. So you wind up with 4x minus 12. Yep, -2x. Okay. So, take on the little guy. Add the 2x. And I believe we did this one as a homework question anyway. I remember it being 11/2, 5.5. Okay. But it asks you to find out what's the value of MR. Well, If you have 5.5 and double it, what do you get? 11, good. So if I take 5.5 and I double it, it becomes negative 11 then, because it's a negative 2 there. What's negative 11 plus 21?
10.
And then just double check, make sure you didn't screw up. If we know that if I double 5.5, I get 11. If I double that, what do you get?
22.
22. 22 minus 12 is?
10.
Hey, we math. That's what we're looking at, guys. The stuff isn't terrible. It's being able to remember what does certain things mean, or what do certain things mean as you're putting them all together. Okay? That's where you have to be cautious with. Yeah. No.
This is the
I rarely do like giant packet stuff. It doesn't. You're right. That's why I do quick little bits and pieces to remind you. And I assign some review problems. I assign pretty regularly for stuff, but I don't generate stuff like that. There are times that I have certain things, but
I love the packets.
then we went and talked about angles. When we talked about angles, a lot of things with angles can be shown and talked about just by looking at their diagrams, having to know how you draw them, having to know what they mean. So think about the different angles we have. We have acute, obtuse, a right angle, straight angles, complementary, supplementary, linear pair, adjacent, vertical, I think there's a couple more. I'll just start with this. What are our acute angles? They're less than 90. So an angle that's acute measures less than 90 degrees. So could you kind of draw what an acute angle looks like?
Yes.
Yeah.
Okay. Anything that doesn't look like it's 90 degrees, like that,
Yes.
tiny.
works for me.
25.
Sure. Obtuse,
Bigger than
90.
degrees.
you just do that. What do you do with the right angle?
90 degrees.
90 degrees.
But how do you show that it is 90 degrees?
Put the square in the corner.
Good. Perfect. Yep.
Perfect.
Gotta have that little square in the corner. Okay. What's a straight angle?
Straight.
It's a line. A straight angle is basically two opposite rays. It's 180 degrees. Okay. Complementary angles.
They add.
Say add up
So
Do they have to be adjacent?
to 90. No.
No.
No. But if I wanted to draw that, I could just say, I can do this for an example, make a right angle, and then put a line out here, call it angle 1 and angle 2.
Yep.
Do those two angles create complementary?
Yep.
Yeah.
Those would be adjacent complementary angles because they share a vertex and a side. We should probably do adjacent angles then real quick. So. I'll come back over to it. Adjacent angles are just two angles that share a common vertex.
And a side.
They share a vertex and a side. They don't necessarily have to be complementary or supplementary or any of that. They just have the same vertex and a side. Remember, complementary does not need to be right next to each other. Okay. And then supplementary.
2 angles, 1 sum is 180.
That's it. Same deal. To draw a supplementary angle, I would just do this again. Draw a line coming down. Call that 1 and 2. Easiest thing to do. Now, that's a good example of an adjacent supplementary angle, otherwise known as. Very good.
I was just.
The linear pair is the adjacent supplementary angles. Because it's a pair of angles that create a line. Two angles that form a line. Hence, linear pair. Crazy how they use these terms where they come up with these things. What's left then? Vertical. What are vertical angles? How are those made?
Isn't it just up?
Could it be sideways?
Yeah.
It, I don't know how to explain it.
When two lines intersect,
Like those are opposite.
And near opposites
Yep.
equal each other.
the opposite ones equal each other. Those two would be the same, and these two would be the same. What do those tick marks in the angles stand for?
The same.
Good, they're congruent angles. Yeah, so I can draw congruent angles also. If I wanted to draw two angles that are congruent to one another, I could do a bunch of different things. If I did this, just put this in the middle, all I have to do is put,
45.
it doesn't even need to do that. If I put two tick marks in there like that, that's congruent. If I draw a vertical angle and I label them as congruent from one another, those are congruent. There's a bunch of ways of doing that. So I think that's all about, I think there's only 10 of them with the angle stuff. It seemed like there was more, but it's really all there was from the angles there. And then again, when we dealt with angles, we had angle bisectors, we had angle addition, all of that stuff still worked. It didn't change any. Instead, you just had these two equal to something as opposed to a line segment. Let me show you an example of that. So if I have something like this, find the measure of angle BCD if angle BCD is 12x minus 5 and YCD is 30 and BCY is 8x plus 9. What's that? Angle addition. Angle addition is the exact same thing as segment addition, but you are working with angles. You turn as opposed to walking straight. You do the exact same stuff. So if I want to write this out, I know I have two smaller angles add up to equal the larger. So I write it out. BCY is the 8x plus 9
Plus 30
plus the 30,
equals 12x minus 5.
and there we go. And notice you're back to the same exact two-step style algebra problem we've been working on. Yes, sir?
Does it matter what order you do them?
Nope.
Okay.
2 smaller equals large. Because what's 3 plus 2?
5.
And 2 plus 3?
5. No, but like, I was gonna put like 12x minus 5 plus 30 equals 8x minus.
Can't do that.
You did 12x minus 5 plus 30?
You can't do that.
You can't do that because these are the two smaller angles. 2 smaller equal the larger.
Just try to
Okay.
find BC. So
Yes, sir.
그런 것
So you have 8x and a 39. Subtract the 8x, add the 5. And what's x?
11.
And there you go. And then it's just a matter of substituting back in. Okay.
Wait.
Subtract 8x, add 5. That's where I got all that. I just did it all in my head. And go from there. Okay? So, let's see.
Oh my god.
Take a second to do this one. Take a second to do that one, please. So So again, just start filling it in. What do you know? What are you going to show? CBA is the entire thing, so it has to equal 168. And just put the other one together.
Set it off.
So that'd be what, 170? Subtract that over. And you get -1 for x. Now, just like we did earlier, did it matter that the x was negative?
No.
Nope. Because you substitute in, what's 141 minus 1?
140.
140. What's 29 minus 1? And last time I checked, 140 and 28 is,
168.
and it works. Okay? So it's not that it's crazy that you get the negative in there. When you substitute in, you shouldn't have a negative angle. Now, remember how I said you can't have negative segments?
Yeah.
Well, you can have a negative angle. You'll learn about it next year. Yes, they are. The negative and on an angle just tells the direction that's moving, that's all. Normally, when you guys get to Algebra 2, when you start worrying about degree measures and radian measures, everything's measured, everything's counted going counterclockwise. So if I go that direction, it's a positive angle. If I go this direction, it's a negative angle. That's all it means. But you'll learn about that next year. No big deal. So, let's see. The last bit of this then. Where's the 5 section? Is when we got into complementary and supplementary. Kind of a decent example of a mixture of vertical angles, supplementary angles.
Yeah.
If I see a problem like this, I have to make the decision on how to solve it. Yeah, go right ahead. Yes, ma'am.
Couldn't you solve for x or y and then you could figure out what x is or what y is because you would know that that's the line?
Yep, that's one way of doing it. One way of doing this is solve the equation for x or y, and then use it as a supplement problem, or solve for x and then solve for y. Because what do you know about the two angles with y's? They're the same because they're vertical. What do you know about the two angles with x's? They're the same because they're vertical.
So we just do it separate.
Yeah, that's the easy. I mean, for me, I think that's the easiest. Subtract the 3x, add the 35, we get 42. So there's your x. Do the same thing with y. Subtract the 5, subtract that. You get 35. There's your x and your y. Okay. It's, again, it's not that the algebra or any of this is going to be scary. It's knowing how to set it up. Do you set them equal to each other? Are they complementary? Are they supplementary? Hey, buddy! Oh, it's almost 8. Yeah, hey, review problems. I want you guys to do the chapter review. It's in the book. I think it starts on page 10, I think. I want you to do 1 through 31. It seems like a lot, but you will fly through it.
Yeah.
Wait, page.
Yeah, it does start on 60. Hey guys, it starts on 60. It goes. They're really, really fast. There's real quick little algebra ones. They're great questions just to look at to help you get ready for tomorrow. We'll collect it before we go. Do not forget your calculator tomorrow. You need one. What's that?
Now
I know they are. Okay? And we'll go from there. We'll start logic then on Wednesday.
I like logic. It's all right.
And then go from there. All right? Exciting.
How did you call